Hi everyone, this is Caitlin Davis, and today I wanted to go over a little bit more in chapter 7. So I feel like we've been talking, quite a bit in that chapter lately, and talking about inferential statistics, t-tests, z-tests, z-scores, that kind of a thing. So I kind of wanted to go over inferential statistics and then different curves, and then going over standard deviations and curves. So to start off, the book says inferential statistics helps us generalize or make inferences about a wider population based off of a smaller sample of it. But this is based off of two assumptions. First is the population sampled has normally distributed characteristics, and the second is that the sample is randomly selected. That is, every individual in the population has an equal chance of being selected. So we can go back to our second assignment, I think, when we went through Excel and we did the mean of each population of different ways we selected through the population. So the first example, we just took the first 5, which obviously that wasn't the normally distributed characteristics, because we took just a random first 5, which gave us all lower statistics, right? And some of the other ones, like the last 3, we had a better chance of randomly selecting people in the population and having a mean closer to the average population. So with that being said, I'm a very visual person, very visual learner. So what I wanted to do was I wanted to draw out kind of the curves and then go over standard deviations. So let me see what I can do here. Share. There we go. Okay, so I've just kind of put up a document already. So I'm just going to draw this. So a regular bell curve is what we hope, or that we think a normal population should be like. So ultimately it's one curve where we go up and down. So you have the top being right about there, and it's equal on both sides. Then a bimodal curve is when we have 2 humps. So I like to think of bimodal and trimodal like camels, depending on how many humps they have. And so it goes up, down, kind of like that. So we still have evenly distributed data because we have 2 equal top areas right there on both sides. And then trimodal is 3. So it's 1, 2, 3, like that. And we have our tops being right there. And multimodal, I'm just going to draw this out because it's what I think of mentally, is kind of like if we went up, then down, then here, and then down, then up and down again. When I think of multimodal, I still think of it being fairly evenly distributed, at least. Like we have quite a few higher points, but at least the data should be fairly spread throughout. And then when I think of no particular pattern, it's more like this, where it's a bunch of different curves and we have no symmetry, no idea about where the area actually is. So that's how I kind of think about it, because we'd still have like high points about right there, but then we still have these little pieces down here that don't really do much. Whereas like here we still have our high points and then maybe a few middles right there. And so for me, that's how I like to think of it. I have to draw things out. I have to visually see it, or else it does not make sense to me. So for standard deviations, we use this to help analyze the data that we have, right? So we want to know how much of the population should be within these particular areas. So if we draw a bell curve, right about like that, not the best drawer, but we should have our first standard deviation about here, our second standard deviation about here, and then our third should be about here. So this area right here should be about 68% of the population. And then when we move on, I'm going to pick a different color. We're going to go here in this shaded area. And all of that should equal 95% of the population. And then we move into the last part right here, which is this blue area. And this should be 99.7% of our population. Now, the rest of it will be all of this outside kind of like grayish area over here. And that'll end up technically equaling 100%. But we use the general rule of 68, 95, 99.7 so that we have a general analysis, right? So it's kind of what I remember from statistics, it was our confidence level. So how confident are we that the mean is within these areas, right? So that first part is 68, or 68% confident that it's within that area, then 95, and then 99.7. If we want to tie this back to z-scores, we can look at, if we wanted to see what, I have a confidence level of like 78%, right? So that should be somewhere right here. That's when we can use those z-scores to help calculate our confidence and our means within that area. Z-scores and T-scores, to me, I think they're fantastic, but they're always a little hazy. So that's something that I'm definitely going to work through more. But I think this gives the general idea and the general visual of what our curves are that we're working with generally in statistics. And then you have to remember that in order to get this bell curve, hopefully, which we hope, is that we still have to follow those assumptions and rules of having a normally distributed population, as well as having each individual having the equal chance of being selected. So as communicators and as journalists who go through and look at statistics a lot, we have to be very aware of selection methods and knowing that the statistics that we are pulling are actually accurate and gave the whole population an equal chance of being selected, because it's really easy to make assumptions and to help prove biases if we just use data that isn't correct or didn't give the whole population the chance of being selected. So I'm just going to go ahead and end this. Hopefully all of that made sense to all of you guys, and we can all learn and grow, and hopefully this helps you visualize kind of the idea of what we're learning to communicate about and how statistics can really be skewed based off of what we choose to pick as data to communicate about. Either way, I hope that helps you all. I hope you have a great day and enjoy the weather turning cold. But either way, have a great time, and I will see you all next time.